Okay, now let us talk about immunoglobinopathies. What is immunoglobinopathies? Immunoglobinopathies simply means abnormal hemoglobin formation. We know that the hemoglobin, it contains 4 chains, okay? These 4 chains, 2 beta and 2 alpha. So 2 alpha, 2 beta. This is the normal hemoglobin. Okay, so now when there is the absence of one chain, so we can say this is alpha 1, beta 1, alpha 2, beta 2. If there is the absence of one of these, this can lead to thalassemia. So thalassemia, this is the situation where the hemoglobin is not having 1 or 2 or 3 or all the chains, globulin chains are absent. This is thalassemia. Now when you talk about the sickle cell simply, there is no losing the globulin chain, but there is a mutation, the missense mutation, which leads to the formation of the other amino acid of the globulin chain. Basically, for the sickle cell, it is the beta gene that become mutated, such that 1, the glutamine is changed to valine. So now let's talk about thalassemia in detail. Thalassemia, it is the problem with the globulin chain synthesis. This globulin chain can be alpha or beta chain. So depending on which of these chains are absent, thalassemia can be classified as alpha or beta. This means that if it is the alpha chain that is missing, the thalassemia can be classified as the alpha thalassemia. Then if it is the beta chain that is missing, then the thalassemia can be classified as beta thalassemia. So remember, decrease in globulin synthesis simply means decrease in hemoglobin, decrease in blood cells, red blood cells, hence this leads to anemia. So now, why this is so severe? Because when there is, we have said the hemoglobin contains alpha, 2 alpha and 2 beta. So meaning if there is the absence of beta, meaning we have the excess alpha such that this alpha remains unimpaired. So this same unpaired alpha, it can cause the precipitation of the red blood cells. Okay? The red blood cell precipitate. And when the red blood cell precipitate, the spleen senses that this is the abnormal cell. As a result, the spleen destroys that red blood cell, which can lead to hemolytic anemia. So let us just consider the normal hemoglobin, just like I've said, 2 alpha, 2 beta chain. Okay? Basically, there are alpha gene. Okay? The alpha gene present in chromosome 16. Okay, this is the chromosome 16. Chromosome 16. Chromosome 16, it has another pair of chromosome 16. So for each chromosome, there are 2 alpha genes. 2 alpha genes. For each chromosome 16, there are 2 alpha genes. These alpha genes, they make the total of 4 alpha gene. Then each gene code for alpha globulin chain. Alpha globulin chain. Then on chromosome 11, there is the beta gene. Okay, the beta gene. So also the beta gene as its friend, its complementary chromosome. But for chromosome 11, there is only one beta gene. Each beta gene, they produce the beta globulin. But they make sure that they produce the globulin to match the alpha globulins that are being produced from the chromosome 16 by alpha genes. So this means that when there is a deletion, okay, of one of these genes, it can lead to either alpha thalassemia or beta thalassemia. So this means that the more these genes are being deleted, the worse the symptoms. Why these symptoms worsen? Because the more the genes are being deleted, the more unimpaired one of these globulin remain. So the more unimpaired, the more the precipitation. The more the precipitation, the more the spleen is sensing. The more the spleen is sensing the absence of it, hence killing the red blood cells by hemolysis. So now, these thalassemias are classified as minor, intermediate, and major. So minor, this simply means the symptoms not showing, asymptomatic in short, meaning this condition is not that severe. It isn't severe actually, but a person with minor thalassemia can be the carrier. Remember, why being the carrier? Because thalassemia, it is autosomal recessive. Obviously, can only manifest when a person has recessive genes, 2 recessive genes. But when the person has a dominant and recessive, it can't show. That person can only be a carrier. The intermediate, it is slightly severe. The major, it is very severe. Okay, so when you talk about minor, it means there is a deletion of 1 or 2 globulin chain. It can be either the alpha or the beta. Then when you talk about the intermediate means there is 3 deletion of the globulin chain. Then major, it means all globulin chains are being deleted. Okay, let's now just consider the classifications. Here we have alpha thalassemia. Alpha thalassemia, just like we have said, this means that there is a deletion of alpha gene with code for globulin chain, which is the alpha chain. Okay, so this alpha thalassemia can be classified into alpha thalassemia, hemoglobin H, and also hemoglobin BAT. So alpha thalassemia either the deletion of 1 alpha gene or 2 alpha gene, okay, or 2 alpha gene. This is not severe. A person carrying this gene is asymptomatic but a carrier. In hemoglobin H, there is a deletion of 3 genes. What are those genes? The alpha genes that code for alpha chain globulin. Okay, so this means that when there is a deletion of 3 genes, the B chain remain unimpaired. This unimpaired globulin, B globulin, it causes the precipitation of the red blood cells. Precipitation of the red blood cells can cause the spleen to sense and destroy that red blood cells. Hence, destruction of red blood cells can reduce the number of the normal red blood cells the body has to have. Reducing in the normal red blood cells number can lead to anemia, which is hemolytic anemia. Then the next one, it is hemoglobin BAT. This is the most severe thalassemia, alpha thalassemia. Why? Because all the genes of alpha genes are deleted. This means that the 2 beta chain remains unimpaired. Because of the excess of B chains, beta chains, it causes severe precipitation which can lead to severe hemolysis. Okay, it is most severe. That's why it is mostly known as eye drops fetalis. This simply means that it causes death of the fetus within the womb, and if the fetus survive, then a baby can die immediately after birth. So this is the most severe alpha thalassemia. Let us go to beta thalassemia. Beta thalassemia, it is caused by the mutation in a beta gene. So this is point mutation of the beta gene. This means that this gene can produce the genes, 2 types of beta, the 2 types of genes, which can be beta or plus. This beta simply means there is no production of the beta chain. Then this one simply means there is production, but the production is very small. Okay, but when there is this B++, it means there is production, but the production is very small for both genes. Then when there is BOO, it means no production at all. So just like I'm from saying, it can be either the beta gene not being produced at all, or the beta chain is being produced but in a small amount, not normal, but in a reduced amount, which is denoted by B+. Also, this one, it is autosomal recessive. Now, let us consider them. It can be also be minor. It can also be intermediate and also major. So when you talk about beta thalassemia minor, this means mutated gene. This can result in the reduction production of the B globulin chain, or no producing the B globulin chain. So minor, it is B0 or BO or B+, where there is a reduction or no producing the globulin chain. Then beta thalassemia intermediate. This means two genes are mutated. Okay, two genes are mutated, and these mutated genes, they do not fail to produce the beta globulin chain, but they produce only in small amount of the beta globulin chain. So this is denoted by B positive. Next, it is beta thalassemia major. This simply means no production of beta globulin chain because of B. So this is BO. So why this is severe? So meaning when there is deletion of all beta, when the beta gene is mutated, it means no production of the B globulin chain. This leads to increase in the free chain. Okay, the alpha chain, the free alpha chain increases, which can cause the precipitation of the red blood cells. So when the red blood cells are precipitated, this can lead to hemolysis. Okay, this can lead to hemolysis. Okay, so the difference between the beta and the alpha is that the alpha, the genes are deleted. Then for the beta, the genes are mutated such that it can either produce the beta chain or fail to produce. If they produce, it means it is in very small amount. Thank you. So now let us consider the last one under hemoglobinopathy, which is just the sickle cell anemia. So sickle cell anemia, this is the mutation in the beta gene, the missense mutation, which is the missense mutation. So this gene, this mutated it is the mutation in the bases. So meaning glutamine, when it become the bases that cause for glutamine become mutated, glutamine can be converted to valine. This result in the formation of the globulin chain, but the abnormal shape, such that when there is little oxygen can cause the RBC to become sickle celled. Okay, so normally the gene or the amino acid that become mutated, it is the 60th amino acid of the beta chain. The beta chain is there, but now the amino acid, which is the glutamine, become mutated to valine. Okay, so when this happens, it causes the hemoglobin to polymerize, okay, and take a spindle shaped, polymerize and take a spindle shaped, which is the sickle cell shaped. What does sickle cell anemia or sickle cell structure of the RBC cause? It is stuck in various organs of the body, which can lead to splenomegaly and the destruction of RBCs even before they reach 120 days, which is its lifespan. So this can lead to hemolysis. So thank you so much for watching my video. If you like it, subscribe and share, and also click the bell icon button. Thank you.